AES is an encryption algorithm. It takes 128-bit input, which is 16 bytes, and it can have either a 128, 192, or 256-bit key, which then corresponds to 10, 12, or 14 rounds of the algorithm. The 16-byte input is organized into rows and columns as seen here, and then multiple rounds of encryption are used depending on how large the key is. The 16-byte is put in, a round key is added, and for one round of encryption, bytes are substituted, rows are shifted, columns are mixed, and a round key is added at the end. This is done for a number of rounds until the last round, where bytes are substituted, rows are shifted, and a round key is added without mixing the columns. At the core of the AES hardware implementation is the file AES core static 128, which controls the algorithm using a finite state machine and has a hard-coded 128-bit key. This file has a number of inputs, including clock, data in, DEC decrypt in, which indicates if the module is decrypting if set to 1. Reset, and load in, which starts a new AES operation, and the outputs are busy, which indicates if the file is currently operating, and then data out, which is the encrypted output. The AES round operations are implemented using separate hardware modules. For subbytes, it's implemented in AES S-boxes. Shift rows is implemented in AES shift rows. Mixed columns is in AES mixed columns. And then the round keys are generated using AES-KS static 28 file, and then these are exclusive ORed. Each round of encryption occurs on a rising clock edge, and then the result of each round of encryption is stored in a register text.